Good day to all of you. Today we shall discuss on data structure. So the definition of data structure. Before that, let us know what is data. Data is any useful information. It will be stored in computer memory for processing. A way of organizing or storing the data in computer memory is called as data structure. It must be stored in such a manner that it can be used efficiently. Efficient usage of data is required as to reduce the time and space consumed by the programs. An efficient data structure also uses minimum memory space and execution time to process the structure. Then what is the need of data structure? The structure of the data and the different components of algorithm, how they are built or constructed. These two are related to each other. The data presentation must be very easy to understand, so the developer as well as the user can make efficient implementation of the operation and use. Data structures provide an easy way of organizing, retrieving, managing and storing the data. Hence the data structure must be first one easy to understand, easy to access, second one. Next third one is save memory. Fourth one, it should take less time for access. Fifth one, modifications if needed must be easy to make. So what for data structures are used? Structures are used to implement ADTs, that is abstract data types. Okay. So ADTs are defined by a set of values and set of operations. Like they are blueprints, like class for objects. They provide both set of values and set of operations. Example stack ADT. It is implemented using either array data structure or linked list data structure. The implementation of an application using ADTs depend on the data structures, because how to implement depends on data structures only. Hence it is very essential to know data structures. So among many data structures available, which one to choose? The data structure should be chosen which gives time and space efficiency for current requirement. For example, stack ADT if we take, it can be implemented using either arrays data structure or linked list data structure. So then both must be compared with respect to time and space they consume. As per the requirement at that time, that implementation must be considered. That is, whether less time of execution is needed or less consuming of memory is needed. Out of these two implementations, that is stack ADT implementation using arrays, that is first one. Second one, stack ADT implementation using linked list. Out of the two, which is providing the requirement at that time, saving time or space, that implementation has to be chosen. What are the advantages of data structures? So first advantage is efficiency. If proper data structures are chosen, they make the program time and space efficient. Means that program will consume less time and space in memory. Okay. Reusability. One implementation, if done, that can be used by many client programs. Abstraction. Data structure specified abstract data types provide higher level of abstraction. Means the programs which use ADTs, that is client programs, they need not worry about how they are implemented. They will have to see only interfaces, not their implementations. Interfaces means which methods or functions are to be used, first one. Next, what parameters are to be passed. After that, how it does the task, that is need not to be worried. Using interfaces, ADTs can be used, which are implemented using data structures. These are the advantages of data structures. Next, we shall see types of data structures, that is classification of data structure. So data structure is broadly classified into two types: linear data structure, non-linear data structure. In linear data structure, again there are two types: static data structure, dynamic data structure. Under static data structure, we have only one type of data structure, that is array data structure. Under dynamic data structure, we have two queues, stacks, linked list. Three kinds of data structures. So in non-linear data structure, we have two kinds of data structures, that is trees and graphs. Okay. So then what is linear data structure? Linear data structure means in that data structure all the elements will be arranged in linear or sequential order. Okay. Then that kind of data structure is called a linear data structure. Example for linear data structure are arrays, queues, stack, linked list. Okay. There is one more way of telling that whether data structure linear is or no. If each element has only one predecessor and one successor, then the data structure is called as linear data structure. Except first and last elements, they are the exceptional. Suppose if we take array in which we have 1, 2, 3, 4, 5 elements, they will be stored in consecutive memory locations. Okay. If first element is stored in first addressed memory location, immediately in next memory location second element, then immediately in next memory location third element, and so on. So this kind of storage which data structure has, that is called as linear data structure. This is one definition. According to the second one, element has, suppose if you take this element, it will have only one predecessor, only one successor, except first and last element. So if this property is satisfied, then that kind of data structure is called as linear data structure. Okay. So what are the example for linear data structure? Arrays, queues, stack, and linked list. Then what is non-linear data structure? Here the elements of data structure, they will not be arranged in linear or sequential order. That kind of data structure is called as non-linear data structure. So the example for this are trees, graph, table. Okay. So that is non-linear data structure. So that completes the discussion of what is data structure, then types of data structure and the examples for that. Okay. I hope you understood. Thank you.